Flying in America feels like death by 1,000 cuts. Delayed boarding, endless gate changes, overpriced snacks, maintenance holds that feel more like excuses than safety. And at the end of it, you still land late. That's not just your bad luck. In 2023, nearly 1 in 5 US flights miss schedule. And the tickets? They're not dropping. Fuel alone eats up nearly 30% of airline costs, so the add-ons keep piling up. But what if a single company could flip this entire system upside down? What if the airline model, as we know it, wasn't just broken, but about to be replaced? Tonight, we follow a thread that's quietly shaking aviation. The Tesla super electric plane. A $79,979 electric aircraft built the EV way, modular parts, shared batteries and motors, software updates over the air, and yes, a real service network. If this works, flying may stop being a slow bleed and start being an efficient, affordable system that makes today's airlines look like dinosaurs. Before we dive in, if you want first-look breakdowns like this, the kind that cut through the hype with clear numbers, hit that subscribe button to help Westech hit 219,743 subscribers. Turn on notifications so you never miss the moment when the next big disruption hits. Now, let's get airborne. How Tesla cuts costs and accelerates production. Tesla doesn't start from zero. They start with a Gigafactory network, some of the largest, most automated factories on Earth. Optimized for modular assembly. Obsessed with repeatability. Ruthless about cutting cost per unit. Translate that into aviation and suddenly, building planes stops looking like handcrafted art and starts looking like cell-line car assembly. Fuselage, wings, battery pack, motor, electronics. Each becomes a module. Each tested independently before joining the final line. Fewer joints, fewer weak spots, faster builds, lower defects. Where could Tesla build this? Giga Texas. Already handling giant castings for cars, it's got the room and muscle for oversized airframes. Add in Giga Nevada, Tesla's battery hub, and you've got energy modules pre-tested and shipped in like Lego blocks. The airplane plant doesn't babysit battery chemistry. It just installs certified packs straight into the frame. And when Tesla wants global reach, Berlin and Shanghai are standing by. Both factories have already proven they can localize supply chains at insane speed. That means cheaper parts, faster scale, and less exposure if one region faces disruption. The chain reaction is simple. Modular production, faster builds, lower costs, repeatable quality, predictable maintenance. Each Tesla super electric plane would carry traceable IDs, digital test records, and shared acceptance criteria across continents. For pilots and operators, that means one thing: a reliable aircraft that spends more time in the air and less time in the hangar. Comment Tesla Giga below if you think this production model is the secret weapon that lets Tesla's plane take off faster than Boeing or Airbus ever could. Tesla's powertrain and energy network. Airplanes live and die by their propulsion. And here's Tesla's trump card. They've already built millions of efficient electric drivetrains. Battery pack, BMS, motor, inverter, a stack that works together like a single heartbeat. That efficiency, huge. Tesla cars hit 87 to 91% system efficiency. Compare that to the gas engines in today's small planes, where most energy disappears as wasted heat. For an aircraft, that means less waste, more range, or more payload. Every watt counts at altitude, and Tesla's drivetrain squeezes out nearly all of it. And the sound? Almost gone. Electric propulsion cuts the roar of piston explosions. The noise drops to the propeller and the wind. A trainer like the Pipistrel Velis Electro already proves this around 60 decibels. Tesla won't aim that low, but it shows what's possible. Quieter cabins, less pilot fatigue, airports that don't sound like war zones. But the real magic is energy infrastructure. Tesla already runs a supercharger empire. The new V4 units? 325 kilowatts and climbing. A Tesla super electric plane could recharge in the time it takes passengers to stretch their legs. Where the grid is weak, a megapack buffer steps in, blasting energy into the plane while sipping slowly from the utility line. Smaller airports? A few Powerwall 3s could handle the auxiliary loads. Do the math. Let's say the pack is 200 kilowatt hours. Fast charging from 10% to 80% means about 140 kilowatt hours. At 250 kilowatts charge rate, that's just over 30 minutes. Long enough to swap passengers, check systems, and launch again. That's not a dream, that's logistics. And costs? EVs already slash lifetime maintenance compared to gas cars. No oil changes, no exhaust systems, far fewer moving parts. Add Tesla's live BMS monitoring, and downtime drops even further. For operators, that means not just cleaner flying, but cheaper flying. What this means for airlines and travelers. Think about what this does to the airline model. Today, short-haul flights under 500 miles are money pits, expensive, delayed, and hated by travelers. That's exactly the segment an electric plane can crush. Imagine Dallas to Houston, LA to Vegas, New York to DC, routes where travelers lose more time at the airport than in the air. With Tesla's system, those hops become as routine and as fast as taking a train in Europe. Costs flip. A modular, shared platform brings unit price down. Cheaper maintenance slashes operator overhead. Cheaper energy means tickets that don't bleed customers dry. Airlines won't want to give this up. Regional players may vanish. Legacy carriers will scramble. And the low-cost startup airlines? They'll smell blood. For travelers, the difference is felt in your bones. Shorter waits, quieter cabins, smoother flights, and lower fares. The experience shifts from frustration to flow. This isn't science fiction. Tesla already has the factories, the supply chains, the charging infrastructure, and the track record of doing what rivals call impossible. The Tesla super electric plane isn't about making aviation greener. It's about making it work. About ending the slow bleed of wasted hours, wasted fuel, wasted patience. If Tesla pulls this off, short-haul aviation changes forever. Airlines don't get to dictate. Passengers do. So the only question left, when this plane lifts off, will you be on board? If you think Tesla's super electric plane is the most disruptive project yet, drop a in the comments. And don't forget to subscribe to Voltorbit for more deep dives like this one. Because the next revolution, it won't wait. Lifetime maintenance costs for airplanes have always been brutal. Oil checks, engine overhauls, endless ground time. But Tesla, they don't play by those rules. Put the pieces together, and the chain reaction is crystal clear. Higher drivetrain efficiency wastes less energy. High-power charging and on-site buffers slash downtime. Standardized modules with remote diagnostics cut maintenance. More hours in the air. Fewer hours in the shop. Lower costs across the board. So the real question is, what does this new machine actually look like? Airplanes are judged by their skin, and Tesla knows it. Their minimalist design language isn't about style points. It's about air. Smooth surfaces and calm airflow because skin friction alone can eat up half of cruise drag. Every seam, every handle, every joint becomes a battle against wasted battery energy. Tesla's answer? Large composite panels. Lighter, cleaner, stronger. Real-world studies show up to 17% weight reduction just by switching from metal skins. Less weight means more flight minutes. And here's the hook. Fewer joints don't just mean less drag. They mean faster maintenance. Instead of rows of rivets, Tesla can swap entire modules. Downtime collapses. Cost per flight hour shrinks. But Tesla doesn't stop at aerodynamics. Boarding becomes its own innovation. Flush EV-style handles cut drag. Cybertruck-inspired steps keep passengers steady. It looks small, until you realize faster, safer boarding translates to higher daily utilization. Lighting? Tesla brings the EV playbook to the runway. Halogen landing lights might last 300 hours. LEDs stretch to tens of thousands. Add 360 degrees cameras and proximity sensors. Suddenly taxiing feels less like guesswork and more like autopilot on the ground. And baggage? Tesla sneaks in a frunk and a flexible rear compartment. It sounds like a gimmick until you realize it preserves center of gravity and keeps turnaround fast. Charging ports with LED rings show status at a glance. In minutes, you're plugged in and pre-checked. So the hook here is simple. Smoother surfaces equals less drag. Larger panels equals faster service. Smarter exterior equals quicker ground ops. All converging to one outcome: a plane that spends more time flying and less time waiting. Question for you: do these exterior upgrades matter more than the battery itself? Comment Tesla Super Airplane if you think the skin is the real secret weapon. Step inside and here's the next surprise. Tesla didn't just design a cockpit. They designed an experience. The philosophy: simple, usable, intuitive. A single massive center display runs the flight interface. But unlike cars, critical switches, flaps, radios, lights stay physical. Reflex actions stay tactile. Complex actions live on screen. That means shorter training time, fewer mistakes, and lower mental load. Hook: fewer taps equals fewer errors. Fewer errors equals safer flights. Seats get the same treatment. Lumbar shaping. Reach optimized for every switch. Wide windshield. Slim pillars. The result? Less strain on the pilot, clearer visibility, smoother ground handling. Obstacles and signage don't sneak up on you. Every taxi and takeoff feels more controlled. Comfort feeds into economics. A Tesla heat pump handles climate without guzzling power. Vegan leather and soft-touch plastics resist grime. Less cleaning, less wear. Quieter cabins thanks to layered acoustics and low-frequency active noise control. That translates to less fatigue for pilots running multiple legs a day. Hook again. Less fatigue equals fewer mistakes. Fewer mistakes equals lower costs. And here's where Tesla's DNA screams through: the digital layer. The Tesla super electric plane behaves like an appliance, not a fragile machine. Lock or unlock from the app. Check charge and remaining flight time. Review maintenance logs. Push over-the-air updates. Even the safety net gets smarter. A cabin camera for monitoring. A health monitoring system that flags anomalies in the battery, motor, or inverter before they become failures. That means downtime is predictable. Repairs are modular. Costs fall again. Hook: more prediction equals less disruption. Less disruption equals more uptime. Outro: 1130 to 1300 hours. So put the pieces together. High voltage exterior that fights drag and cuts downtime. High voltage interior that reduces errors, fatigue, and cost. High voltage, a digital backbone that keeps the plane flying like it just left the factory. At $79,979, the Tesla super electric plane isn't just a product. It's a gauntlet thrown at the old guard. So here's the closing hook. Is this the twilight of Boeing, or the sunrise of a leaner, smarter sky? Tell us below. And don't forget, subscribe to Volt Orbit and hit the bell, because in the next chapter, we explore how this plane could rip the heart out of the airline business model itself.